All right, let's do this. So today we're going to start talking about Scala and writing programs in this new language. Oh my goodness, the volume of this room. First, a few things that I didn't mention, these links at the top of the website that I didn't mention on Monday. Let's talk about these real quick. I'm going to be streaming each lecture on Twitch. We're live right now, so if you want to follow the lectures live on Twitch, I'll try to watch the chat, and any TAs in the room will try to watch the chat so we can get there, but no guarantees on whether I'll do that or not. The TAs will also post the videos on YouTube, so each lecture will be posted on YouTube. There are also 3 lecture sections. There's this one, another one at 3, and another one at 4 p.m. So if you want to watch the other ones live, watch me say the same things over again, see if there are differences or whatever. And also all 3 of them will be posted on YouTube, so you have that access to all of them. Maybe there's something I don't know, maybe you just want to watch the other lectures. I don't know why, but that'll be available to you. I'll also be doing 312 on the same channel, so if you want to check out that content, I suppose that's there for you too, as a side note. Anyway, Piazza and Discord, these are our more communication apps. Piazza, you're probably familiar with both of these platforms. Piazza, that'll be the more official avenue if you want to contact myself, the TAs, you want to ask official questions about the course, especially if you...
Be in Discord.
What's that?
If you want to shit talk, be in Discord.
Oh, yeah, I'm saying that. So Piazza is the more official channel, especially if you want to post something about your code. You make a private post on Piazza, and the TAs have a post on there, Piazza guidelines and stuff. Follow those, make sure you're following those. If you're posting your code publicly, either Piazza, Discord, I don't know, Twitch chat, whatever. If you're posting it publicly, just know that's an AI violation. Don't do that. If you need to talk about your code to the TAs, to myself, emailing me is probably the slowest way to do that. I might get back to you a month after the deadline in some cases. But if you make a post to instructors on Piazza, that's the best way, because then myself and all the TAs have an opportunity to answer you and talk to you about that. Don't post your code publicly on any avenue, though. So Piazza is more the official channel. That's where myself and the TAs will answer your official questions about the course. And then there's Discord. This is more of a free-for-all. I won't spend much time there personally. Some of the TAs are in there. They'll be just bullshitting around in there quite a bit. If you just want to chat about the course, if you want a place to just chat, sometimes blow off steam, there is a CSE 116 channel in the Discord, so please keep all the trash talk out of that channel and keep that channel related to the course in some way. If you want to post memes, there's a meme channel, etc. You can do all the other stuff. But just where you want to hang out with other people from the course. There are also a bunch of alumni in the course. They use the same Discord server each semester. This is, I think, the 3rd semester I'm using Discord. 3rd or 2nd or 3rd, I forget. I lose track. So there's a lot of alumni in there as well, and soon to have taken the course. So if you want to bounce ideas off of them, if you want to talk about 220 and 250 and see what's coming up, there's plenty of people in that channel, in that server, to talk to about all those kinds of things. GitHub, when I show examples in the course, for the most part, most of that code is going to be in that GitHub repository. I recommend cloning this early in the semester so you have all that code on your laptop. Clone this repo. We won't be talking about cloning in lecture, will we? If you don't know what cloning means, ask in lab, office hours, make a Piazza post, etc. Somebody will post a tutorial and help out the class on that. I don't have lecture time to be able to talk about that. And then finally, AutoLab. Late last night, I added you all to AutoLab. I know some of you were asking earlier that you don't have access to AutoLab. It's because I didn't upload the roster yet. Now the roster is uploaded. You should be able to go to AutoLab and see some of the content. This is where every time you finish a learning objective or an application objective, I'll post it on the appropriate field in AutoLab. So this will be your official record of what you've completed in terms of those objectives. So you always know where you are in terms of those objectives. There's no surprise at the end of the semester where I'm like, JK, you didn't have that one objective, so you fail now. None of that. You're going to have your official record that we can both access so you know exactly where you are in terms of completing those objectives, learning and application. And the first lecture question, the lecture question for today is this lecture question 1, first Scala program. The second one is also live if you want to jump ahead and do Fridays, but the first lecture question is live here. For AutoLab, you'll go to the assignment, tell me that you didn't cheat, and then submit. Choose your zip file of your project, and towards the end of today's lecture, I'll show you how to write your program in IntelliJ and create a zip file so you can submit it on AutoLab. So those are our 5 big external links. And I want to go to slides. I want to go to the right slides. There's a lot of slides. I spend half my life looking at slides, so I have a lot of them open. But with that, any questions about the course structure or anything related to the course before we get into some content? Let's do it. I'm at the end of my slides. I want to be at the beginning of my slides. All right, so if you are looking to get ahead, I won't always post the slides ahead of time, but I guarantee they'll always be posted by 1 p.m. on the day of the lecture. They'll be posted at least before this lecture. When I do have them posted ahead of time, the second slide is always going to be the lecture question for that day. So if you want to look ahead and see what I'm asking you to do for that lecture, so you know what to be reading, what to study up on, that lecture question will be that very first slide after the title slide. So for this lecture, we want to write a simple program, a straightforward program in terms of you know the concepts of how to solve this from 115. We just want to know how do we simulate, how do we write this same type of program using Scala in 116. So for this, you have to write a method that computes shipping cost, where you have a flat rate of $5 for everything under 30 pounds, and then 25 cents per pound for every pound over 30 pounds. And you can have fractional cents, so if it's 30.4 pounds, is my math right here, it should be $5.10. I don't know if my math is right there. I can't think that quick when standing in front of 200 people. But anyway, so that's the lecture question for today. It's essentially an if statement. If greater than 30, do one thing. If less than 30, do another thing. Takes in a double as its input, the weight of the package you want to ship, and returns a double, which is the cost of shipping that package. So that's what we want to write by the end of today. That's what we want to be able to do by the end of today. So let's start where every programming course starts. Hello, world. I'll go through a tutorial at the end of the slides. I'll open up IntelliJ and show how all this will work. But very briefly in the slides, start a new project in IntelliJ, choose Scala, and choose Idea project. You can choose SBT if you feel like having a somewhat different structure. But if you do Idea project, you know that's going to be, it'll fit the structure that you're going to see throughout the course. It'll just make your life a bit easier. If you are already familiar with Scala for whatever reason and you prefer SBT, go for it. If you prefer that structure, it just changes the directories that are created for you. But Scala, Idea, and then we can write our first program. This is in the repo, just like the examples I'll show, in a package named Week 1 Basics. So if you want to open up that code, follow along. If you want to do that, at this point, most of you are probably still setting up IntelliJ, probably not at that point to clone a repo yet, but this code is available to you. That's the point I want to make. So here's Hello World in Scala. Run this program. It'll print Hello Scala to the screen. Yay, our first program. So let's pick this apart and see what the new things are that we're talking about in Scala that we didn't necessarily see in Python and JavaScript. Most of it's just syntactical. The theme of these first 2 lectures is going to be, you know how to do this stuff. Here's the syntax of how to do it in Scala. So I will go very fast through this stuff. We're not really learning new concepts. We're just seeing new syntax. So I will rip through a lot of this real quick. But let's see how to do this in Scala and what the syntax is for Scala. So first, The first new thing is the package declaration. So every file, we'll call them objects, we'll get to that as the next thing, but all the code you write in Scala must be contained inside a package. And that package declaration must appear at the top of your file. So this code is in a package named week1.basics, and this package name very strongly should, I almost had must here, but technically you don't have to, but you very, very strongly should match your package name and your directory structure. So for example, this code, this file, is in a directory named src. That's a source code directory, src for source, directory that's created by IntelliJ when you create the project, and then it's in a subdirectory week1, and then a subdirectory basics. So that package name is matching the directory of my project. So whenever I look at the directory, I know what packages there are, and whenever I look at a package, I know exactly what directory to find that file in. It makes things easy. If you're coding in Java, and if you've programmed in Java at all, with a package name must follow the directory structure. Scala is a little looser on that must, but I'd say you definitely still should match the directory structure. This code is in an object named hello. An object, we'll talk all about object-oriented programming in a few weeks here, but we do need to know what objects themselves are first, very early in Scala. So an object is a package of variables and functions, and when a function is inside of an object, we call it a method. So you hear me saying the words method and function, they'll seem interchangeable, but when a method, what would be a function is inside an object and defined with the def keyword, def for define, then it's a method. And I'll try to keep those straight throughout the whole semester. I might slip up once or twice. But right now we're working with methods only, so if I say function, I'm probably wrong. So an object is a collection, so to say, of variables and methods. The object name of at least the top level object name, we won't worry about that yet, but the object that we're creating is going to be the top level structure of the file that we're writing, and the file name very strongly should match the object name. So this is in a file called hello.scala. We use the .scala extension for Scala. So this file is in src week1 basics, the package, and then hello.scala, hello being the object name. The object, the scope of an object in braces, just like JavaScript syntax for functions, we use braces to define a block of code, and an object is that top level block, and all our code is going to go in there. Now we have this main method. We're defining a method using the def keyword. So def, define a method. We're defining this method named main, and we're using similar function syntax that we've seen in Python and JavaScript. There are a few differences. We'll talk about those later in this lecture. For now, the main method is always going to have this header. We're going to write exactly this in our code. And in fact, in IntelliJ, if you just type main and then I think tab or enter, I forget. I got muscle memory at this point. If you just type main, though, it'll complete the rest of this for you. That's something you shouldn't have to memorize. It'll do that for you. And then equals, and then whatever you want to run when you run your program. When you run this file as a program, Scala, IntelliJ, the JVM, whatever, is going to look for a method named main with this exact header. And as long as you have a method with this exact header, that's the code that's going to be executed when you run your program. So we have this file named hello.scala in a directory named week1/basics. We have this main method, and when we run that file as a Scala program, we're going to run this code inside the block of the main method. So new syntax, a lot of new phrases, but the ideas are very similar. Like in Python, this would just be print hello Python. We have a little more structure that we have to add to a Scala program. In JavaScript, it would just be console.log, hello JavaScript. We got a little more structure here. Yes?
What is the unit keyword?
So the question is, what is the unit keyword? We will get to that later. Actually, that's not till Friday, so I'll give you a quick answer now. If you're exposed to Java, it's the same as void. It means nothing. It doesn't return anything.
That's a return type?
Yep, so that's the return type, and this is saying this method doesn't return anything. Since this is called by something outside of the program, it wouldn't make sense for it to return anything unless it's, let me back off that. It can return error codes and stuff, but it doesn't really make sense for a main method to return to something outside of the program, because that calling code might not be Scala code, so it wouldn't use a Scala return. We don't need to get into those details, though. It just means it returns nothing for Scala methods. And when I get questions, since we're streaming on Twitch, I will repeat the questions, just so you know, just in case you're wondering why I repeat questions, just so the mic picks it up. Okay, let's talk about two topics today, methods and variables. These will be the two big things that we talk about today, and then conditionals towards the end. So let's expand on this. Like I said, we're going to move quick. Let's see a bit bigger program. We're going to define a method. They call it a method, right? We're going to define a method and call that method from our main method. So we have one method calling another method, giving it a value, returning a value, all that fun stuff. All that stuff that we did early in 115. Let's see the Scala syntax for it very quickly. So we have this program. Now we're naming it first object. We have a main method where our program is going to start. We're going to run 3 lines of code when our program runs. And one of those lines of code is going to be a method call to another method that we define. So let's pick this apart piece by piece and see what's going on here. Even not being exposed to Scala at all or knowing Scala syntax, you could probably read through this code and figure out that we're going to print 14 to the screen. But it's one thing to read through it, another thing to write this code on your own. So let's pick apart what's happening here so you would be able to write your own methods and call your own methods. So here's our method definition. We're defining a method just like Python, Java, JavaScript, whatever your background is. If you came from our 115, our new 115, our old 115, if you've programmed in high school and skipped 115, if you're transferred in, whatever background language you have, this part should look at least mostly familiar to you. The definition of a method. We're going to have the keyword def to say I'm defining a method. In Python, this was def. In JavaScript, this was function. In Java, you'd have a little bit more there. You'd have the access modifier and the return type in front of the method. Anyway, def, the name of the method, the parameters and types, the return type, and then the body of the method, the definition of this method. The big difference here, if you're coming from Python JavaScript, is for every parameter, we must define the type of that parameter. In this method, we have to say it takes one input, which I named input because I didn't get creative on this one. It takes one input named input, and it has to be of type double. If somebody tries to call this method with something other than a double or something that can't be automatically converted to a double, we're going to get an error. Program won't run, nothing's going to happen. We'll get a compiler error, just our whole program is broken. We have to give this a double, we have to define exactly what types it takes, and it has to be called with those types. This is what we call strong typing. Scala is going to enforce types. It's going to, we have to specify each type, and it's going to enforce those types. You have a question?
Where the main method is.
Where the name of the method is?
The main method. Like this location.
This entire thing. What does, you mean, could this entire definition be down here?
Yes.
Yes, it can. So in a language like C++, the definitions would matter. You can't call a method before it's defined in the file. We don't have that in Scala. It doesn't matter. It's Scala's going to look for every method definition and then run the code after that. So we have to define the types, and the input name, the parameter name, and the parameter type are separated by a colon. So my input parameter name, colon, parameter type. And if I had multiple parameters, it would be comma, second parameter name, colon, second parameter type, and so on and so forth. But whenever we have a parameter name, colon, and then its type. We also have to define the return type of the method. This comes after the parameter list, a colon, and then the return type. We have to follow that syntax. The colons have to be in the right spot. All that stuff has to be in the right spot. So after the parameter list, colon, return type, and this method has to return a value of that type. So here I'm saying this method is going to take a double and return a double, and Scala is going to hold me to that. If I don't take a double and return a double, or if I call this without a double, or if my return value is not a double, my program is broken, it's not going to run. So Scala is very concerned about types, which will be the first major adjustment coming from Python, JavaScript, if you're coming from that terrain, is the strong typing. We have to, Scala will enforce our types, we have to define our types. And the next thing you'll notice, this method doesn't have a return statement. There's no return explicitly stated in this method. And if you can add returns, Scala does have the keyword return, and it does what you would think it would do. But its usage is discouraged by the Scala community just as a standard practice for Scala. We don't use return statements at all. Instead, the last statement of the last expression, there's a nuanced difference between the two. The last expression that's evaluated in the method call is the return value. So here I only have one expression that's evaluated, input times 2. That's going to be evaluated. It resolves to a value. Since 2.0 is a double, it's going to resolve to a double. I have a double times a double. Going to resolve to a double, and that value that resolves to is the return value of this method. That's going to be what's returned. It's just whatever the last expression to be evaluated is during the call of that method. Yeah.
What's the difference between an input and an argument for the method?
So what's the difference between an input and an argument? So I misspoke a little bit. We don't input is kind of a looser term that's more ill-defined, but parameter and argument. This is a parameter because I'm defining it with the method. So this method takes a variable named input of type double as its parameter. When I call, and that's a variable declaration. When I call this method, I'm going to give it an actual value. That's an argument. So I'm going to provide an argument to the method call. That method contains a parameter, and that argument is going to be assigned to the parameter. So if you're defining a method, it's a parameter. If you're calling a method, it's an argument. And then I kind of use the loose term of input, which doesn't have necessarily a definition. It could refer to both, I guess. It's more of a looser, vaguer term. I was looking at my variable name, and I just said input. I meant parameter. So that's a method definition. Now let's use this method. Let's call this. First, we're going to start with a variable declaration. So we're jamming method definitions, calling, and variable declarations, all in the same slide here, all in the same example. I'm going to create a variable using the keyword var, which will create a variable. I'm going to name it x, and I'm going to have the same style as when I define declare a parameter. Name x, colon, and then type double. Then I'm going to assign it the value 7.0 right in this line. When I use the keyword var, this is going to be a mutable variable, meaning that its value can change. It is a variable. This will be the same as If you took 115 last semester, it'll be let in JavaScript. It'll be similar to that. It'll be the same, very similar rules as let. Now I have my method call. This syntax should look very familiar to you. Multiply by 2, just my method name, and then the input, whatever input I want to call it with. And then that's going to resolve to the last expression that's executed during the call of that method. I'm declaring another variable named result, and I'm not defining my type in this one. So this is our first deviation. I said you always have to define your types all the time. Scala cares about this all the time. Very true, Scala does care about this. Sometimes you can leave off the type. You can ignore the type in a variable declaration, never in a parameter declaration. But in a variable declaration, you can sometimes leave off the type if Scala can infer the type. Scala's very smart about this. It'll look around and try to figure out what type you meant, and it'll add that type to that variable. So in this case, I have a variable that I'm defining, and I'm immediately assigning it the return value of a call to multiply by 2. Well, multiply by 2, I said has to return a double. There's nothing else it can return. There's only one type that it could possibly return. So Scala goes, oh, I got you. That returns a double. You must know, result can only be a double. I'm not going to force you to type it. That's redundant. I'm just going to figure out that you're assigning it a double. You must want this to be a double. I'm going to make result a double. So in this case, result will be of type double because there's no other meaningful choice for it to be. Scala is going to infer that you meant for that to be a double. So I don't always have to put those types if Scala can infer the type. In fact, I could have done that here as well. Since 7.0, the literal, it could either be a double or a float, or any other literal that can take that syntax. I think only double and float in Scala. So it'll infer that that's what you want it to be. It'll infer that you want that to be a double. I don't think it'll ever assume float for that. All right. Any questions on this example before we move on? Yeah.
Why would you want to do it? Wouldn't that hurt readability? Like,
To not-
want to do bar instead of just say it's double?
Yeah, so the question is, why would you ever leave off the type? Wouldn't that hurt readability? Yeah, and it comes down to preference at some point. In lecture examples, I will almost always add the type in there. I wanted to leave it off just once just to show off Scala's inference there. And it depends, as you get more comfortable with your language, with the language and stuff, sometimes it is clear what the variable is going to be. Especially here, I could leave off double here because it's clear what it's going to be. But yeah, in general, it's always better to add the type to make it very explicit. This is what I want this to be. This is what it is. So anybody reading your code, you're absolutely right, knows exactly what types you mean. Yeah.
So you said when we do the main, def main, we have to follow the exact wording.
Yep.
But if we use any other, we define any other function, we can name it the function name we can choose anything, and the parameter input can be anything. We can name anything.
Correct. So the question is, for main, we have to have this specific header. But for other methods, we can choose whatever. That's true. We can choose any valid name. I don't know the rules for Scala off the top of my head. I believe that it can't start with a number and a few other rules like that. But as long as it's a valid name, you can name it whatever you want. And the parameter names, you can name it whatever you want. And the only exception to the main method is this parameter name, you can actually name whatever you want. We always, it's standard practice to call it args. Those are the command line arguments. But you technically could rename that. But you have to have a method named name that takes an array of strings and returns unit in order to tell the language that that's the method that we want to, that's our entry point into our program.
Just one more question. What's in JavaScript we use semicolon at the end, and in Python we use, how does Scala define different statements?
It doesn't. So the question is Scala. In Java we had semicolons at the end of every line. With Scala we don't. We just don't. The new line character is going to be the end of that statement, and Scala will, Scala's good about figuring it out.
Continue to the next line. Is there anything like in Python we add slash, and then it counts
I don't know all of the rules right off the top of my head, but there are certain cases where you can go to the next line, certain cases where you can't. I believe there's just certain breakpoints where you can have, for example, if you have, I don't have a good example off the top of my head. But typically a new line character is going to be the end of that statement. It might always be the case. I'd have to look up the exact rules on that one and get back to you. But we don't have semicolons. When you write a Java program, you have semicolons at the end of pretty much every line. In most cases, they're redundant. Most cases, they're not really needed. So Scala just said, let's stop doing that and got rid of them. In most cases, you can just have a new line character. I've never ran into a situation where I was just like, oh man, I really need to tell Scala that this is the end of the statement. So I don't know the exact rules off the top of my head, but I'm sure there's some nuanced case where you might get tripped up in Scala. I just don't know it off the top of my head. Any other questions with this example? Yes.
In the main method, where you declare the variable x, use the semicolon, and then right after that, the result, use the equal sign.
So in this x,
Yeah, use a semicolon after you declared it, and then for result,
yes. So this is so the question is, I used so this is a colon, not a semicolon. It might be hard to see from up there. But I used a colon here, but I didn't use a colon here, so what's the difference with that? So the colon is how we define the type of a variable. So with variable x, I'm saying I'm going to explicitly define the type of this variable. So I have the colon there to tell Scala the next thing I type is going to be, the next thing I physically type is going to be the type of this variable. And then I type double to say this is the type of the variable x. With result, I didn't do that. Sometimes we can get away with not defining the type because multiplied by 2 is always going to return a double. Scala looks ahead to that, figures out how I'm using this variable, and infers that this should be of type double. So I don't have to explicitly type colon double on result. If I did add it, the code would have the same exact effect. But in some cases, you can leave off the type. Maybe in hindsight, I shouldn't use that example for the first example with typing, but I wanted to show off Scala's type inference there. Question?
The type double is similar to int?
So int can't have a decimal portion. Double can have a decimal portion, would be the difference. And we'll talk more about the differences between those two in Friday's lecture. So I'll table that discussion till Friday. Yeah.
Real quick, other than new lines, does Scala read any other white space?
Does Scala read any other white space? I'm not up to speed on all the specific rules. I'd have to get back to you on that one as well. Some of it does. For example, in between, there has to be a space between bar and x, but other places, doesn't matter so much. I'd have to get back to you on the exact rules on that one. It's not like Python, if that's what you mean. There's no like indentation or spaces. None of this leading white space on each line matters at all. None of the trailing white space is going to matter at all. So in that sense, no. It's more like JavaScript syntax if you're coming from 115. All right, let's get these conditionals. So this is the last example we'll see today. Let's look at some conditionals. The syntax for this, also very similar to JavaScript. As I just mentioned, a lot of the syntax is similar to JavaScript. Let's look at a method call with a conditional. Call it a few times and get what you would expect. If you look through this program and kind of guess what's going on here, you should be able to guess that. I have some threshold for a large item, some threshold for a medium item, and then everything below that is going to be a small item. And I want to do some comparisons. If the input is above the large threshold, that's a large item. If it's above the medium threshold, but this was already false, if this is true and this is false, we have a medium item. And if both of these are false, I have a small item. So if I call this with 70, 50, and 10, I should get large, medium, and small from this program. So that's the high level. Okay, what do we want to accomplish here? We have some method, takes some input, I left out some units and stuff, but let's say it's the weight of an item, maybe it's the weight of a package from the homework, and I just want to roughly say, is this a large, medium, or small item? And have some conditional to be able to determine that. So let's go through this and talk about a few different things. I did a few things different in this one than I did in the last example. Let's talk about those. So the very first thing you'll probably notice, I used val instead of var. Val is another way that we can declare values instead of variables. If we want to declare a value instead of a variable, we'll use val, val, short for value. This means that the value cannot change. A variable, it's variable, it can change. A value cannot change. Once we declare it and assign it a value, that value cannot change. If we try to change it, Scala will say, I'm not running your program because you told me that's not going to change, and then you changed it. You lied to me. I'm not doing it. I'm not running your program. So val, these cannot change ever. Large will always store 60. Medium will always store 30. If you try to reassign a val, Scala's going to yell at you. This is similar to const in JavaScript. If you want a value that cannot change, it'd be const in JavaScript, val in Scala. Yeah.
So if you were to do input times 2, would that change the actual value of the input?
If where would you want input times to?
Like, say you just had it at the top, like before the vowels. Like, would that actually, like,
If I did input equals input times 2,
yeah.
it actually wouldn't let me do that because, I'm not 100% on this. I'm like 95%. I'm pretty sure the parameters are vals that I wouldn't be able to reassign them. I'm not 100% positive on that, but I don't think it would let you reassign. If it does let you reassign, then it would change that value of input. We'll go to the code. We'll have a little bit of time. I'm going to have to try that one because I want to give a more concrete answer than that. But for now, val cannot change, var can change. Yes? Okay. And our conditional. Syntax, really not much to talk about. You've seen this in JavaScript. It's the exact same syntax. I don't think I really need to talk about it. There's nothing special with Scala that I have to say about the syntax of it. It's just the keyword if, conditional, block, else if, conditional, block, else, block. You've seen that before. Yeah.
Don't need to assign a value to input to get the conditional score?
It's assigned through the argument.
Oh, sorry.
Okay. So the syntax is similar, but what I do want to point out, and what trips up so many students on this first lecture question, is the return value of a method, remember, is the last statement, the last expression that's executed during the call of that method. Well, here the last statement that I have is dependent on this conditional, on this if statement. So the return value of this method is actually dependent on this conditional. So if this is true, if input is greater than or equal to large, greater than or equal to 60, large, just the statement of containing the string literal large, is the last statement that's executed during the call of this method. So large is the return value in that case. If this is false, when input is 50, for example, this is false and this is true, medium is the last statement that's executed during this function call, so that becomes the return value. So the return value is dependent on this conditional, since the conditional is the last statement of my method call. So I'm changing the return value just by putting my conditional at the end of the method. But if I had any code after this conditional, it would completely break my method unless I was doing something like storing large, medium, or small in a variable and then returning that variable later. Other than that, if I put the string literal null right here, or just any other string, that string would always be returned regardless of the value of the input. So I'm taking advantage of the fact that the last statement executed in a method is the return value, And this conditional is going to decide what that last statement is, so I can change my return value based on the input. So this is something new, just combining a few things that we just saw. If statements that you've seen, but that idea that the last statement in a method is called, I'll repeat that a whole bunch of times because I'll still get that question a couple hundred times. It gets even trickier when we have loops. You got to have something after your loop, or else the last iteration of the loop is going to determine the return value. We'll talk about that Friday. All right. So in the last 8 minutes, I want to run through how to set up a project in IntelliJ and how to, but I don't have solutions up here. I don't think I do. How to create a new project. So on the course website, on the schedule for today, there are lots of links on how to get IntelliJ set up, how to get it installed. There was a review session, 4 to 6 yesterday, that was posted on Piazza. I forgot to announce it in this lecture. I apologize for that. There will be office hours starting up soon. Lab next week, the TAs will be able to help you get IntelliJ set up, installed, and running and everything. Once you have IntelliJ set up and running, you'll go to File, New Project. From the slides, we'll do Scala idea. We'll name this project. For the sake of time, I'm going to leave it as Untitled 7. We'll be talking about these next 2 steps at length. There will be Piazza posts. We'll talk about this. This takes a while to get set up in some cases. But we'll run Java version anywhere between 1.8 and 1.11 will be suitable for this class. Once you go up to 1.12, there are features that were removed from the JDK that we need. So up to 11, and Scala version 2.12. 2.13 is also incompatible with some of the things we'll do. 2.12, and then the highest version of 2.12. I'm using 2.12.9 right here. But the versions, to make sure everything meshes well, should be those ones. Click Finish, and it's going to create a project for us. Do it for me, come on. There we go. And you'll see in the sidebar, I created a project. I left it as Untitled 7. Maybe I shouldn't have done that. But anyway, what it did was create a few directories for me. Idea, which is IntelliJ settings, things like that. But more importantly, this SRC folder, this is where all our source code is going to go. When we write code for our program, we'll put it in the SRC folder. So I'm going to right-click SRC. I'm going to get out of this Zoom. I'm going to New Scala Class. I want to create a new object. I'll just call it Lecture Object. Oops. Oh, no. And this I can zoom in. I created that right in the SRC folder. I didn't mean to do that. I meant to create a package first. If I go to New Package, and I believe the lecture question needs to be in a package named Lecture. I'll create a new package named Lecture. I did that by right-clicking SRC, going to New Package, and then I'll drag my... Usually you would right-click your package and create a new object from there. If I create a new object in a package named Lecture Object in a package named Lecture, and I can see that in my sidebar I have SRC for all my source code, then my package structure, which is just the package Lecture, then Lecture Object is a Scala object. It is enter. I pay attention to what I was doing that time. So, and then IntelliJ has a nice setup, a nice shortcut. Just type main and then hit enter, and it's going to generate that main method for you. And now we can start writing some Scala code. Maybe I want, what were we testing? I know what we were testing. All right, so let's create a method. Of it take an int and return an int. And I wanted to test this. What was the question? Okay. So I was right. I was 95% sure. I didn't want to say anything just in case I was wrong. But we can't reassign to the parameter. It does give us the reassignment to val error. Scala is going to treat those parameters as values. So we can't reassign to the value. But let's have this method just return something silly, number plus 3. Let's call this. Let's create a value x. We'll call that with the input 9, the argument 9. Let's just print that to the screen. So we have just a simple program, simpler than the examples we saw in lecture, or in the slides. And now I have a few options here to run, just a few ways IntelliJ has to be able to run. We have these green arrows here, the go buttons. We can run our program, or we can go to the file, right click, and go down to run, which is the way I just feel like doing it right now. So we'll run this program. So Scala, right now it's compiling my code, which is something we'll talk about starting Monday, I believe. We'll get to that. It's compiling my code and then running it, starting with the main method. So it's going to run this line by line and print out the 12 that we expect there. So we have our first program. We're super happy. And maybe this was the lecture question. Write a method that adds 3 to a value. So once I have my program and I want to submit this to AutoLab, I'll go to File, Export to zip file, and then I'll save it somewhere. I'll just put it in my Downloads folder, I guess. Well, you'll save it somewhere. Just pay attention to where you're saving it so you know how to get to it. Save that zip file. Head over to AutoLab. Submit. I saved that in my Downloads folder, untitled 7.zip, and submit. And I'm going to get, you can see my hand-in history here. You'll get one of 2 outcomes. You'll get the 0. And it'll say your lecture question did not pass all of my tests. Or you're going to get the 1. It says lecture question complete. That's all the feedback I'm giving in just about every case for the lecture questions and for the most part for the homework as well. You're going to get very little feedback on the actual questions. A big part of this course, the first part of this course starting next week, is testing your own code and making sure that it works without relying on AutoLab. So you get very little feedback in this course. And with that, that's the whole example I want to show. With that, I'll see you Friday.